Hello everyone, today we're going to go over the Blind 75 in C++, and today we're working with merge case sorted list. Now, before we get started, feel free to pause the video if you're following along. For whenever we are breaking down any problem, we always need to ask ourselves what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally what our output's going to be. So, feel free to pause the video if you're following along to write out the comments. And just breaking down the problem right now. You are given an array of k linked lists called lists. Each linked list is sorted in ascending order. Alright, we know exactly what our input's going to be. Merge all the linked lists into one sorted linked list and return it. And we know what to do with the data. We need to merge all the linked lists into one sorted linked list. And return a merged linked list. We will need to create a dummy linked list to return from the head. Few indications. And so the technique for us to be able to replicate this problem, just looking over the example, again, it's pretty self-explanatory. We're given a list of different linked lists, and the k is going to be arbitrary. So we have 1, 4, 5, 1, 3, 4, 2, and 6, all separated by commas. They're all different linked lists, and then we need to merge them all together, and then finally have this output. So the technique that we're going to be doing is going to be a priority queue with a merging algorithm. So that means, in particular, what we will do is that we will, for one, we would need to create a structure to compare the values of each node from one list to another. That's just the key indication over what we need to do. For queues, in our case, what we will be doing for this data structure, queues in general operate on the principle of last in, first out situation, much like in the case of a grocery cart line, where people are going in throughout the line and then they happen to appear out of the line. In some retrospect, that's how queues operate. And so the steps that we would need in order for us to be able to go through are the following. One, we're going to create a Boolean function called compare to compare the values of each linked list, labeled list 1 and list 2. Second, we're going to initialize a priority queue that orders the nodes by their values. The third step, and then for each list in the input, if the list is not empty, we will add our first node to the queue. Then the fourth, we will initialize a new head and current pointer for us to return. Then we will scan the queue, and while the queue is not empty, we are going to move the current pointer forward after adding the node, and then we will return the new list from the head, which will be called dummy. So the way how this is going to work out accordingly are the following steps. Step 1, step 2, step 3, step 4, step 5, step 6, step 7. A thing to note, since we're going to be comparing the values, we're going to create a separate function all the way at the top, and we're going to start comparing each of the values accordingly. So the way how it will look is that this is how we create a new function that will be called later. We have a structure called compare, and what it's going to be is that it's going to be a Boolean function, or really just an operator, that will incorporate the parameters of a list node, indicating for list 1, and then list node for list 2. And then what we will be doing is that we will return a comparison between the list 1's value if it's greater than list 2's value. That'll be in the case of if we have, for instance, list 1's value being greater than the other. So if we have 5, we're going to place this 5 over here. That's what we need to do in the very first step. And then we're going to call this operator later on throughout the rest of our structure that we're going to create for steps 2 through 7. So that means for step 2, we are going to be creating a priority queue, which will look like this. It's going to incorporate a list node. Then it's going to have the vector of the other list node. And we're going to call upon compare our structure at the top. Oh yes, also another thing. Don't forget this. Hang on. Let me just double check. So it's right here. Just want to be sure I got all the comments right. Okay. It's supposed to be right here when having the new structure. So then, let me just double check. Yes, we have a priority queue. We're going to call that PQ. And for step 3, what we will do is that we're going to have a for each loop. I don't know why it's not letting up, but we'll check to see. This will be PQ for priority queue. Then we will have our for each loop in step 3. For each list in the input, we're going to put it inside of a priority queue. So we're going to have auto list of lists indicated by the parameter. Up here, lists. And then we are going to, I'm just going to move each of these steps away to make it easier on you folks. Just keep it there for reference. And then step 7 is going to be our return. And then just put it up here, and we'll just go side by side accordingly so it's easier to see. So then in our for each loop for step 3 is that if we have a list indicating that it's, we have elements in our list, we're going to put that inside of our queue. So it's going to PQ push for our list, which will be called. Then for step 4, after we have added in our priority queue, we're going to create a dummy list node, which will be the linked list that we'll return. So new list node, this is how we initialize it, -1. Then we will have a list node for the current, be the dummy, and the current list node is going to be the one we're going to manipulate throughout 5 and 6, finally returning the dummy, because the dummy is technically the head in this case. So what we'll be doing is that while the queue, PQ, is not empty, it's calling upon the empty function from the STL library for queues, and then PQ, we're going to pop the smallest node from the queue, which will be a list node for a temp. We're just going to label this as top. And then what we will do is that PQ pop. So we get the very top of it. And that will be our temp that we have. So current next. The reason why we do current next is to label out each node accordingly prior to calling our head. So if we were to have PQ pop, we can literally just do the same thing up here and do it accordingly. We just happen to put the list node for temp and call it for pop. But we're just doing it for the sake of clarity. And looks like for step 5, we're going to remove the current pointer. Then the next part, what we will have to do is that we have an edge case inside of our while loop. We still have more nodes to push in after we pop the queue. This would be A. So just want to clarify in this part. We will also push that inside of our queue. So it will be if temp for the next following nodes, pq push temp next, and then what we will do is that we will also get the following nodes after, and continue the while loop. So that will be part B. So we are going to set the next current, we're going to set the next node after the current node accordingly and still go through the while loop until we finally have finished scanning throughout the rest of our queue. And finally, what we will do, this will be B, not step 6. Apologies on that. And then this will be step 6. There we go. Then finally, we will return the head, so dummy, for next accordingly. And then B, we're going to move the current pointer after adding the node. There we go. That's more like it. All right, so just to give a rundown, what we're doing is that for step 1, for the solution is that we are creating a structure called compare where we're getting the values accordingly to sort all of our following elements. And once we have already done so, we're going to initialize a priority queue where once we scan our list, after we compare, we call upon compare for our priority queue. Our priority queue is going to push all the following values while comparing them as well into the queue. And then what we will do is that we're going to create a new list as a result from everything that we have already set inside of our priority queue, and then finally return our dummy. So it's technically 3 parts. 1, we have to create a structure called compare that will compare the following values between the previous list and the next list based on their value. And once we have already sorted, then what we're going to do is that we're going to put that sorted, we're going to call upon our sorted function from our priority queue, and we're going to sort all of our list for each element in our lists, linked lists that we are already given, and then push inside the queue. And after we have done so, we're going to scan the entire rest of the queue from the top all the way to each node accordingly, and finally return our new linked list, which is the merged linked list of everything that we have already scanned. So let me just run this just to double check. All right, and don't forget your semicolons. All right, it passes all the test cases. All right, and now just to give a rundown and breakdown of our space and time complexity for the following solution is that our time complexity is O of n log k, where n is the total number of nodes in all linked lists, and k is the number of linked lists. And this is because we need to traverse all the nodes of n, and each insert operation in a priority queue takes log k time. Meanwhile, our space complexity for the solution is O of k, because at any time the maximum size of the priority queue is k, since we only push the head of each linked list into the queue. And so yes, this was merge case sorted lists. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.